welcome back. Procedure: how to determine whether data have a normal distribution. All right, so we have we have collected a bunch of data. How do you know whether that data is normal distribution? The following guidelines represent some useful devices for determining whether or not data follow a normal distribution. First, build a histogram. Make a histogram. For a normal distribution, the histogram should be roughly bell-shaped. Okay. Second, outliers. For a normal distribution, there should not be more than one outlier. How do you check for outliers? Well, use a box and whisker plot. Outliers are those data values that are above the third quartile by an amount of 1.5 times interquartile range, or below the first quartile by an amount less than, greater than, okay, 1.5 times interquartile range. So you are way beyond the third quartile or way beyond the first quartile. So what is that way beyond? That way beyond is 1.5 times interquartile range. Okay, so if a data item which is way beyond these two values are outliers, well, a normal curve should not have more than one outlier. Okay. Second, the third way, now look for skewness. Normal distributions are symmetric. Okay. One measure of skewness for sample data is given by Pearson's index. Pearson's index is, well, you take mean of your sample, subtract the median, right? Divide by the standard deviation 3 times this quantity. That's Pearson index. If the Pearson's index value is greater than 1 or less than -1, you have skewness. Skew distributions are not normal. Another way, look for normal quantile plot. This plot is provided through statistical software or on a computer or graphing calculator. The using technology feature gives a brief description. Okay. Now examine a normal quantile plot of the data. If the points lie close to a straight line, the data come from a distribution that is approximately normal. If the points do not lie close to a straight line or show a pattern that is not a straight line, the data will come from a distribution that is not normal. Okay, so this requires some package. Consider the following data. They're rounded to the nearest integer. So they have given us a bunch of data. Question is it normal or not? Look at the histogram. That histogram looks somewhat symmetric. It's not exactly symmetric, but it is approximately symmetric. Okay. Now, if you look at the box and whisker plot, you have a minimum here, a maximum here, and that's the first quartile below, second quartile right in the beginning, and third quartile right over here. Okay, you will find only one outlier. Okay, so both these graphs indicate some normality. All right, so there is, now looking at the Pearson's index, you find X bar, that is the mean. You find median, that is that, and you find standard deviation, that is that. So they have used a computer package, Minitab, to find the mean and the median and the standard deviation. Now look for Pearson index. It is using this formula, if you recall Pearson's index formula, 3 times X bar minus median over S. If it's greater than 1 or less than -1, then you are skew. All right. So skew is not normal. So, well, we are not beyond -1. So this does not detect any skewness. Now if you look at the normal quantile plot, the points look very close to a line. Okay, straight line. So the data appear to come from a normal distribution. Interpretation. The histogram is roughly bell-shaped. There is only one outlier. Pearson's index does not indicate skewness. The points on the normal quantile plot lie fairly close to a straight line. It appears that the data are likely from a distribution that is approximately normal. All right. So this is one way of detecting. So these are the ways of detecting, right? Histograms, look for outliers, look for skewness using Pearson's index, and then a computer package software to say, look for quantile plot. These are ways to detect normality or otherwise. So this completes section 7.3, the theory for it. We will continue with problems in the next videos. Until then, bye.